Bismillahirrahmanirrahim. We are studying chapter 8, that is automatic transmission, the transaxle principle. In today's lecture, we will be talking about some more parts or subparts of the automatic transmission, in which we will talk about the automatic transmission fluid. We will talk about the pumps, we will talk about the bands, we will talk about the multiplate clutches, and we will talk about accumulator. Now, let's start with our lecture. Okay, hydraulic components. Hydraulic components and control system. Automatic transmission fluid or generally known as ATF is highly refined oil with a viscosity similar to SAE 20W-20. SAE means Society of Automotive Engineers and grade is 20 winter-20 oil. So the automatic transmission fluid is a highly refined oil with a viscosity similar to that of 20W-20 oil and is specifically designed for use in an automatic transmission. So it is specifically designed to be used in your automatic transmission. Newer automatic transmission fluids are lower in viscosity and are similar to SAE 0W-10 oil. So the newer automatic transmission fluids which are in the market nowadays, they are having the rating of similar to that of SAE 0W-10 oil. The purpose of this automatic transmission fluid and functions are: it has to transfer the power in the torque converter. So the automatic transmission fluid, the first purpose or function is transfer the power in torque converter, provides hydraulic pressure in clutch and servos, basic purpose, hydraulic pressure in clutch and servos, lubricating bearings, bushings and gears, transfer heat to cool transmission parts, provides the correct friction for clutch and band application, act as the medium to control transmission, shifting by traveling through passageways, acting on walls, and being directed by solenoid switches. So the first important purpose or function of automatic transmission fluid is it has to transfer the power which is generated in the torque converter. Then it provides the hydraulic pressure in the different parts, that is clutch and servo, and oil. Basically, it's an automatic transmission fluid and it possesses the viscosity, so it has to lubricate the bearing, bushing, and gears. And the secondary property of the oil is that it has to transfer heat to cool transmission parts. Then it has to provide the correct friction for clutch and band applications. Act as a medium to control transmission shifting by traveling through passageways, acting on walls, and being directed by the solenoid switches which are used in the automatic transmission system. Now, three basic types of automatic transmission fluid includes non-friction modified, friction modified, and highly friction modified. There are three types of automatic transmission fluids which are non-friction modified, friction modified, and highly friction modified. Now, we see this automatic transmission fluid cooler. We have this automatic transmission fluid automatic transmission here. So these are the two green lines which are showing the cooler inlet and the cooler outlet. Basically, this is the automatic transmission fluid cooler. Inside the radiator, we have this arrangement. So one is the inlet, which is outlet of the automatic transmission fluid. Automatic transmission is the coming of fluid is coming to the cooler inlet, and after cooling down, it is going back to the inlet of the automatic transmission. So the automatic transmission fluid is routed from the torque converter, where most of the heat is generated, to the radiator where it is cooled. The fluid then returns to the transmission of the transaxle to lubricate the bearing and the bushing to perform its different purpose and functions. Now, further cutaway figure of this bank, we have this upper bank or the side bank, the automatic transmission cooler, which is inside. Here is the radiator cap. A cutaway of a typical radiator showing the automatic transmission cooler. The heat from the automatic transmission fluid is released to the engine coolant. Around here we have engine coolant. The engine coolant also warms the fluid as soon as the coolant flows through the radiator. So heat transfer is going on in the radiator from the transmission cooler. Now, it is from the engine. We have a warmer or cooler, then we have an auxiliary cooler here, then the thermo valve, and then the radiator. So engine coolant from the engine block flows through the passage in the cooler oblique warmer, and then out through the thermo valves to the upper radiator tank. Thermo valves uses a wax element type valve to control the flow of the engine coolant through the case-mounted cooler oblique warmer. The thermo valve improves the automatic transmission fluid warm-up times and maintains the automatic transmission fluid temperature within the optimal operating range between 170 degree to 190 degree Fahrenheit or 77 degree to 88 degree Celsius. So this is the optimum operating range of the automatic fluid transmission fluid. So these are the further description. On the another part of the automatic transmission system is the pump, which produces this hydraulic pressure. So there are different types of pump. The gear type pump. This one is your gerotor type pump, and this is your vane type pump. Depending upon the pressure which we required in this system, we use different types of these gear pumps. Now, from the gear pumps, we have the pressure regulating. Well, let's see, we have a gear, your pump is generating a pressure which is coming from this inlet port, this pressure regulator, and the fluid is accumulating in this portion. This valve is closed, exhaust port is closed here. When we have enough pressure here, this will move this piston against the tension of the spring, and this will unlid the exhaust port. So the excess of the pressure which is having in your automatic transmission fluid will goes out. So this is how it's works. This is your right chamber, this is your left chamber, and this is the transfer port, inlet port, exhaust port, and this is spring action. When pressure on the face of the pressure regulator valve overcomes the spring forces, means the inlet pressure is coming with the help of the fluid here. When it overcomes the spring forces, the spring compresses, the valve moves to open the exhaust port. So this exhaust port will be open and the fluid will be circulating from this exhaust port. And this how the pressure regulation is maintained with the help of this pressure regulation valve. Now, a complex diagram of the pump and the valves. Let's take this is a variable pump is at maximum output position until the regulator valve moves enough to decrease volume by rotating the slide against the force of the priming spring. So the position of the pump constantly varies depending on the needs of the transmission, transaxle, and driving pump. So this is your priming spring, this is the intake, and this is your pump or rotor vane rings. So this, if you see this black portion, this continuously rotor is moving. So this priming spring is maintaining the pressure inside. Here you see it is compressed, here it is decompressed, and these valves, which are there, the pressure relief valve or pressure relief valves, they maintains the pressure in whole of the system. Now, the pressure control solenoid controls the main line pressure, which is in turn controlled by the powertrain control module, PCM, or the transmission control module, TCM, by applying pressure to the spring side of the pressure regulating valve. Now, let's see. We have this pressure control solenoid here. We have electrical connection here. With the help of this electrical signal, this pressure control solenoid valve operates. We have exhaust, we have a boost, and this is your mainline pressure which is coming in. From this mainline pressure, from which is coming from the pump, it goes to the boost area, and from this boost area it goes to the boost sleeves, and then it pressurizes this spring, the pressure regulating valve, and the excess of the uh, pressure or the fluid goes to the reverse boost. So this how, and this all is controlled by this pressure controlled solenoid switch, and that the current or the electrical signal is given by the powertrain control module, PCM, or the transmission control module, which is there on the transmission system. Now the next part in the automatic transmission is the bands. Let's see what the bands are doing in the transmission system. Transmission bands are holding or braking devices. So bands, these are basically holding or braking devices. In the concept of a planetary gear system, I have explained to you there are three members. First, in which we give the input. Second, we hold the member, and third, from where we get the output. So how to hold that member is with the help of these bands. So the planetary gear set member held is known as a reaction member. A transmission band stops and holds one planetary gear set's member so that another member can react against the held member and develop output motion. So we are giving input to the one gear, which may be sun or maybe planetary carriers or maybe the ring, and holding either of the one and getting the output from the third member of the planetary gear set. So this is how this like this. The reaction member has a control surface for the bands to ride on. So the reaction member, which we are holding, has a control surface for the bands to ride on to stop that motion of those part, known as the drum. The band directly affects the drum, and the drum directly affects the planetary gear set's member. We will see in this figure. The band provides a holding force around the outside of the drum, closing tightly to keep it from turning. To repeat, a transmission band is holding a device and is not capable of driving any member of the planetary gear set. Remember this thing. A band provides a holding force around the outside of the drum, closing tightly to keep it from turning. To repeat, a transmission band is holding device and is not capable of driving any member of the planetary gear set. So let's see how this band is directly affecting the drum. Now let's see. In this figure, gear set members are attached to a drum and are held stationary when band applies. Now the intermediate band, we have this intermediate band, then we have a high reverse clutch drum here, and the front sun gear, the input shell, and the rear sun gear. So this is the basically bands which rides on this clutch drum or which holds the one member. We have different types of transmission bands, come in several designs and thickness. One is split band, that is double wrap. The other is thick heavy band, which is single wrap, and light thin band single wrap, which is like this. So these are the different types of bands which we use in the automatic transmission system. Now, hydraulic server, another component of this, we are having hydraulic pressure is applied here. This is the applying port. Hydraulic pressure is building up, and then it is compressing the spring and the piston, and the pressure is going out from this. A servo uses hydraulic pressure to move piston, which applies a bend. So basically this servo mechanism, pressure is applied to the bands which holds the drum in the automatic transmission system. Now this servo pressure is coming here. It is moving the spring, which is linked with the graduated link rod, and here the band is attached to it. One end of the band is held stationary and the other end is attached to the servo. So this is like this. Now the next part of the automatic transmission system is the multiple plate clutches. The multiple plate clutches consist of plates, a piston drum, retainer, and snap rings. We will talk about these plates. What are those plates? The piston, the drum, retainer, and the snap rings. Hydraulic pressure acts upon the clutch piston, which moves in the drum. The piston movement compresses the plates together to provide either a holding or driving function. When the pressure is released, the piston returns to an unapplied position via a return spring assembly. So basically we have a spring here, the snap ring and spring. The hydraulic pressure acts upon the clutch piston, which moves in the drum. The piston movement compresses the plates together to provide either a holding or driving function. When the pressure is released, the piston returns to an unapplied position via return spring assembly. The entire assembly is commonly known as clutch pack. So let's see this multiple plate clutch. We have this clutch drum here. Then we have the piston seal rings here, this yellow one. And then we have this piston arrangement. And then we have spring and retainer not shown here. Then we have these plates here. There are two types of plates. One, this blue in color, these are the steel disc or the separator plates, and the yellow disc, which are friction disc clutch plates. In the steel plates, we have the outer splines, and in the friction disc, we have the inner splines. Then we have this pressure plate, and ahead of this pressure plate, we have this snap ring here. An exploded view of a multiple plate clutches clutch pack assembly. So see, this we have a snap ring here. Then we have these plates, the friction plates, the steel plates, and down below we have the piston and the piston seal rings, and this is your clutch drum. Now the plates of a multiple plate clutch assembly consist of a friction plate alternated with the steel plates. So we have a one friction plate, then we have a steel plate, then friction plate, then steel plate, then friction plate, then steel plate. So one by one, alternately, we have this type of a arrangement in this multiple plate clutches. A friction plate, also called simply a friction, has a rough surface friction material applied to the both faces. On the friction plate, on the both side of the friction plate, we have a rough surface which provides the friction. A steel plate, also called simply a separator plate or steel, has a smooth flat surface finish with no friction material. So basically it's simply a separator plate or steel plate which do not have any type of material on both sides of the faces of the steel plate. Some transmissions may not have separate friction and steel, but rather combine them. One side of the plate will be coated with frictional surface while the other side is flat material like steel. So in some of the transmission in which we are using the multiple plate clutches, we do not use the separate friction plate and the steel plate. We have a same one plate on with one side we have a friction material and other side it is a plain without any coating. So collectively the friction and steel plates are called clutch plates. So these are the clutch plates. Friction plate and steel plates are collectively known as clutch plates. Now, multiple plate clutches, generally the steel plates have splines on the outer edge, I have explained, while the friction plate have splines on their inner edge. Each set of spline engages matching splines on a, so each set of spline, whether it's a internal or external, outer or inner, matches splines on a shaft, drum, planetary gear set members, or transmission case. So they are engaging some of these assemblies, sub-assemblies. Now, clutch operation. To apply the clutch, pressurized fluid enters the drum through an internal passages in the input shaft. When the clutch applies, hydraulic pressure acting on the piston squeezes the two sets of the plates together to mechanically connect the two components that engages the splines of the plates. So clutch operation, the multiple plate clutch operation is like this. To apply the clutch, pressurized fluid enters the drum, that is the clutch drum, through an internal passages in the input shaft, which the power is coming. When the clutch applies, hydraulic pressure acting on the piston squeezes the two sets of the plates together to mechanically connect the two components that engages the spline of the plates. Now the fluid acts on the piston and moves it against return spring force. So the fluid which is acting on the piston moves it against the return spring action force to clamp the clutch plates together and hold them against the pressure plate. We will see in this figure. So these are the clutch plates and snap rings and the pressure plates. We will see this. The friction between the plates then locks the clutch drum to the hub, so that the clutch drum, which the friction between the plates then locks the clutch drum to the hub, causing them to turn as one unit. So when it is locked, it will move in a one unit assembly. To release the clutch, hydraulic fluid to the applied side of the piston is cut off and exhausted through an exhaust port. So we will stop the supply of an hydraulic fluid with the clutch assembly, and with the return spring action and the absence of the hydraulic pressure, the piston will return to its original position. The piston return spring, which are compressed when the clutch was applied, are now free to expand and move the piston back, allowing the clutch plates to disengage. So let's see this. So we have this clutch applying fluid here with the help of the input shaft. These are the ports or the opening from where the hydraulic pressure is applied. These are the retainer ball assemblies, and these are the snap rings, release spring and applying ring. We have these plates here, clutch plates here, clutch applying action, plate assembly. So these are linked with the drum here. So clutch piston assembly, spring assembly, snap rings, wave plate, reaction plate, and steel plate, and friction plates, and backing plate, snap rings. So hydraulic fluid under pressure enters the clutch housing. Hydraulic fluid under the pressure enters the clutch housing and exert a force on the clutch piston. So it exerting the force on the clutch piston here. The clutch piston forces the steel plates and the friction plates together, creating a shift here, and it's locked here. Now, in a holding clutch, one set of discs engages splines on the transmission case, and the other set engages splines on the drum. So, this is your case. We have these steel discs supplying to a case, and we have this fluid pressure, and we have a friction disc splines here, one with external, one with internal. This is your drum. Friction disc spline to a drum. So applying piston input shaft. In a holding clutch, one set of a disc engages spline on the transmission case and the other set engages splines on the drum. So by applying the clutch, the drum is locked to the case. So this drum is locked to this case by applying this clutch here. Now the last part of today's lecture, the accumulator, which is the subpart of one of the automatic transmission system. The purpose and function. An accumulator cushions or dampens the applying force during a shift. So what does the accumulators do? An accumulator cushions or dampens the applying force during a shift. An accumulator reduces hydraulic pressure surges by temporarily diverting part of the fluid flow in a hydraulic circuit into a parallel circuit or chamber. So what does the hydraulic accumulator do? An accumulator reduces hydraulic pressure surges by temporarily diverting part of the fluid flow in a hydraulic circuit into a parallel circuit or a chamber. So basically it reduces the surge or the peak vibration which we experience in the conventional transmission. Here we do not have the conventional transmission, we have the hydraulic pressure, so it's nullify the peak values, the surges, by temporarily diverting into the hydraulic circuit, that is in parallel circuit or chamber. The accumulator can be described as hydraulic shock absorber because they absorb or reduce the shock of engagement of the clutch or band. So basically the accumulators can be described as hydraulic shock absorber because they absorb or reduce the shock of engagement of the clutch or bands. So that's why we do not feel a jerk in the automatic transmission system as compared to the conventional transmission system. The divergence allows pressure in the main apply circuit to increase gradually and provide a smooth engagement of the band or clutches. So this diversion allows the pressure in the main applying circuit to increase gradually and provide a smooth engagement of the band or clutches. Piston types accumulators looks piston type accumulator lock and function much like servo pistons. Piston type accumulator looks and function much like servo piston. In fact, some piston type accumulator share a bore with one of the transmission servos. This common bore design is known as integral accumulator. So this common bore design is known as integral accumulator. So with this, we comes to the end of our chapter. Not chapters for today's lecture.